Hello teacher, I'm Pedrosa and today I'm going to explain our first partial exam, specifically the second part, which is the three last open questions. So the first problem says, a fish tank has a width of 1 feet, a height of 2 feet and a length of 4 feet. What is the volume of the fish tank in gallons? Here we have some measures or conversions. 1 meter is equal to 3.281 feet. 1 liter is equal to 1 cubic meter and 1 gallon is 3.785 liters. So to start with, we need to know the volume of the fish tank. So we'll use this given formula and replace each value of the problem. So we'll have volume is equal to 4 feet times 1 feet times 2 feet, which will be volume is equal to 8 cubic feet. Now that we have 8 cubic feet, we need to convert this into cubic meters to eliminate the cubic feet. So we know that 3.28 feet is equal to 1 meter. So we repeat this 3 times to eliminate the cubic feet and get cubic meters. We also know that 1 cubic meter is equal to 1,000 liters, so we write it here. We write the cubic meters down to eliminate the meters up. And we also know that 3.785 liters is equal to 1,000 liters. So we'll eliminate the repeated values. So this cubic feet will eliminate 1, 2, and 3 feet. This cubic meter will eliminate 1, 2, and 3 meters. And this liter will make this liter. So we'll have an operation like this. 8 times 1,000. Here we have the gallons. That is the only unit we need. And we also have 3.88 to the cubic or to the cube, I don't know, times 3.785, which will be this that can be done on the calculator, and the result will be 59.8966 gallons. And my mistake on the exam was in this part. All the process is fine, it's completely correct. However, on the calculator I placed the wrong digits, so the answer went totally wrong. However, the process is fine. And that's it, that's our first problem. Now for the second problem, it says, in a physics lab, students arrange vectors on the floor with yarn. One team shared their base vectors that were used during the activity. Here we have some vectors, a given formula, and we have to determine the amount of yarn used during the activity, that is our distance. And we also have to determine the magnitude and direction of the resultant from the vectors. So to start with, we know that these vectors are on polar form. So we write them like this, and to get distance we simply sum all the magnitudes. However, here we have a formula that we need to follow. So this formula will replace the values. For example, here we have 2 times a, that it will be the same as 2 times 5.65 plus b, that it will be 3.45. See that here the sign is positive because on distance it doesn't matter if you have a negative or a positive sign, it will always be a sum or addition. So it will be plus 3.45 plus 3 times c, that is equal to 3 times 4.42. Solving this on the calculator, we'll get something like 11.3 plus 3.45 plus 13.26. This answer will be 28.01 meters. This will be our distance. Now, to get point B, we'll need to get that displacement. To get a displacement, we need I and J. For I, we need to multiply the magnitude times cosine times grades. Times the grade or the angle. Sorry. So we get I, that is this one, and to get J we need to multiply the magnitude times sine times the angle. this can be done easily on the calculator. So we'll have these values, this one for A, this one for B, and this one for C. Now this isn't our final displacement because we have the same formula, this one we need to follow. So we need to multiply all the values of A times 2, so it will be 0.7863 times 2, that will be this value, and we also have to multiply this one times 2 to get this one. Now in the case of B, we have that B is negative, so we need to change the signs of I and J, which will be a positive negative. In this case will be negative positive. Now for the case of C, we need to multiply all of this times 3, which will be this one. Now we can finally solve this operation, that will be minus 12.1455 I plus 9.1098J. This is our displacement. However, we need the magnitude and the direction. To get the magnitude, we need to get the square of I, which is this value, plus the square of J, which is this other value. And then we'll need to get the square root of this, and it will be 15.1823 meters. It is very important that you place the meters, kilometers, or any unit that you have. But this will be the magnitude of our displacement. Now to get our direction, we'll use SOHCAHTOA because here we have opposite and adjacent. Opposite is equal to J and adjacent is equal to I. Now to get the angle, we'll use arctan or tan minus 1. So we'll use arctan times our opposite, that is 9.1098 over minus 12.1455, which will be minus 36.8719. So we have that this value, we can see easily that this value is on the second quadrant, because we can see that I is pointing towards left and J is pointing towards up, so it will be somewhere like here. And if we follow this value, we'll have that this will be our angle. However, this isn't right because we need something just like this. We need this value, not this one. So what we have to do is to sum 180, or to add 180 to get the difference. So this is 180, and this one over here is 180 minus 36.8719, which will be 143.1280. This will be our direction. Finally, our last problem says, assume that a car moves 21 kilometers with an angle of 49 degrees with the horizontal, then 17 kilometers with an angle of minus 59 degrees with the horizontal, and 58 kilometers with an angle of 147 with the horizontal. What is the distance traveled, the car's displacement, and the direction of its displacement? So first of all, we'll need to pass these values into polar form, which are this one. Now, to get distance, we already know that we need to add each magnitude of each vector. So we will have 21 plus 17 plus 58, which will be 96 kilometers. Now, to get the car's displacement, we'll need to pass this polar form into rectangular form. This can be done again with multiplying the magnitude times cosine or sine times the degree. So to get I, for example, for the first one, we'll need to get 21 times cosine times 49, and to get J, we'll have to multiply 21 times sine times 49. We need to repeat this process with each vector, and then we'll need to add or to solve each vector to get minus 26 32.811i plus 32.8661j. This will be our displacement. Remember to always write kilometers or meters depending on with what you're working with. And finally, we need to get that direction of the displacement. To get that direction, we need to use again arctan and the opposite and the adjacent. So we'll use arctan times 32.8661 over minus 26.11, and we type this into the calculator to get minus 51.5477. However, this isn't our final answer, because if we can see this vector is on the second quadrant and this angle is on the fourth quadrant, so we'll have to add 180, because as you can see, this value, this one is our angle, our degree that we just got. However, we need to pass it on the other quadrant, so we'll add 180. This is 180, and we'll need to rest 180 minus 51.4477 to get specifically this angle, this one. So we make the 180 minus 51.5477, and we get 128.4522, and this will be our final answer.